Now when we look at the safety hazards of this whole assembly, what we can see here is that the moment you hear or see the Leidenfrost effect, so again that's now very visible in the beginning, that is indicative of the protective layer of gas of the nitrogen that is between the liquid nitrogen and the surface to disappear all at once, which means that the surface has almost the same temperature as the liquid nitrogen. So after this Leidenfrost effect, you should know that actually every metal surface that is now in contact with the liquid nitrogen actually has the temperature of liquid nitrogen. And since the liquid nitrogen itself, you can dip your finger in there, this is not really the dangerous hazard that we have in this situation. The actual danger comes from these metal surfaces. So always be aware that you should restrain yourself. If something goes wrong and you think in an instant, oh, I need to grab this out, that will be quite dangerous, because this metal surface now is in the order of minus 190 degrees Celsius, and that will freeze to your skin. So whenever you want to move metal or manipulate metal that is in contact or in liquid nitrogen and that isn't violently bubbling, you know that that is too cold to handle with your hands. So always make sure that you have a pair of tweezers or a pair of pliers next to where you're operating, so that you can use those to handle metal objects. A second hazard is, now that we have liquid nitrogen in the middle and we actually start to fill it and we have too much liquid nitrogen in the center, what will happen is the ethane will not become liquid but actually solidifies. And if I bring this out, you can now see that on the tip, it's white, we have solid ethane blocking the tip. So there is no liquid ethane coming out. And if you hear the sound of filling stops and you lift the tip out of the liquid nitrogen, of course that will rapidly warm up. But be aware that the ethane is still in this tip, so there's still pressure coming from the bottle. And when this warms up, you can, there we are. That's then the dangerous situation that you create, is that the moment that ethane, that solid ethane disappears, you suddenly get a burst of ethane coming out, which might splash into your liquid nitrogen, or worse, splash liquid ethane up. This is the reason why when we fill, I always in the beginning go a little bit up and down to make sure that any solid ethane that might form at the tip is not present or is actually removed or broken down, so that the tip doesn't become clogged. But be aware that when the ethane is not flowing anymore and you have a blocked tip with ethane, the moment you take that out, you'll have this potential hazard. So the best thing you can do is then close the bottle and then take the tip out, but still be aware that there might be ethane coming out of that tip. So now that we're filling, when we're almost filled at the top, the time comes to pull out the pipette tip or the tip of the filling nozzle. If you actually keep the nozzle too deep, like I'm doing now, all the way to the bottle, and I'm closing the valve, what will happen is you instantly saw that coming up. There's now very clearly the ethane via capillary force is sucked up into the nozzle. Again, we have a very dangerous situation, because if I now take this out, and now I do it slowly, so it slowly drops back. But if I would do it fast, like I do now, and there we are. And you have to be aware that, as you now know, liquid nitrogen on your skin is not going to create burn marks, but liquid ethane is. So liquid ethane is going to make a serious burn mark on your skin. So the most dangerous components you have in this assembly is now actually the liquid ethane, that the moment it's formed it's at minus 80 degrees, but at its melting temperature it's at minus 180 degrees. and these metal components that are in touch with the liquid nitrogen that can be as cold as minus 196 degrees. So those are the ones that create serious burn marks. So the best way is when you're filling and you're almost at the end of filling it, so the liquid level is at the top, make the nozzle come up slowly, 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 so that there is not a lot of surface in which this ethane can be pulled up via capillary force. And while moving the nozzle up, slowly close the valve on the ethane, so that there's a little bit of pressure of flow still coming out, and there's only a small tip of the nozzle in the ethane. And then when you're done, you simply take it out and then close the valve, so that there is very low pressure and a little amount of ethane that can drip out. So now that we show all these hazards, you can see there's a lot of solid ethane at the edge of the cooling spider, because we're not working very neatly. Now we can still use this ethane, and when you're starting, you're gonna definitely see some cases when you end up in a situation like this. And when you have this situation, the only option you sometimes have is basically to break off this spider from the top. And we do that with a pair of pliers, so be aware all of this is extremely cold. So you break that up from the top and you take it out. Now the hazards here are this is solid ethane, which is very, very cold. And also the spider itself comes from the liquid nitrogen that is also very cold. So be aware, and you see now that solid ethane has evaporated quite quickly, but this spider is now extremely, extremely cold. And when we place it to the side, you will see that at some point it starts to frost over. And again, similar as with the nitrogen tank and nozzles that come out of a nitrogen tank that have just been filled, you might know how cold this is because you have just used it. But if you now move to a different area with your freezing equipment and you leave this on the bench, and somebody else comes in the lab and sees this frost and just thinks it's maybe slightly below zero and would grab it, that will be also a very dangerous situation. So always be aware that when you leave these cooling spiders, you do that in an environment where everybody knows what it can be, and or that it is locked away or safely, or you don't leave it until this is properly warmed. You might also have the question, when is it safe to actually touch this with your hands? And the answer is rather simple. We again use physics and our eyes. Now at this moment we see it turns white, and this is frost coming onto this cold metal surface. Now the moment the frost disappears and the spider is wet, that means that the temperature must be above 0 degrees, because below 0 degrees you can have frost, above you cannot. So you are 100% certain that you can touch this with your hand the moment the frost disappears. Another hazard you can have is when you refill the liquid nitrogen level in your ethane tray. Now we have special places to do that on the outside. The reason also to do it on the outside is that you can see that this ring, even though the cup is made from polystyrene, and polystyrene doesn't conduct heat very well, so you see that we can just touch this with our hands. It will get cold from the vapor that comes up here, and there will be some frost on the outside. Now that frost is not a hazard, but it is a source of contamination. If that will be on the inside and you would flush that in there, it will be in the same area as where you store your grids. And these frost crystals will show up as very, very big ice crystals on your specimen. So you want to avoid as much frost as possible coming into your liquid nitrogen. So your liquid nitrogen needs to be as clean as possible. So whenever you refill, try to not pour those crystals from the surface, and try to pour from the side. Now, you could also pour it straight in the center, but since the nitrogen will come out like this, the chances are very high that you're gonna hit the ethane. And when you do, the ethane freezes over. And again, there is a safety risk here, because at some point if there's something warm coming in or it warms up, it can splash or it can shoot. So in this case it didn't do so, but there are cases where when you pour it in too sudden, the ethane might splash out, or the nitrogen might splash out and take some liquid ethane with it, again causing a risk of getting some burn marks. Now the source of the splashing can come from the fact that the liquid below it can warm up and builds up pressure underneath this crust and then break through it and then have a certain splash. So now that the spider has been on the bench top for some time, you can now see that the frost on this spider is gone and it's wet. You can see I can now touch it with my hands because I know it's at least 0 degrees, which will not cause any burn marks. When you have finished freezing your specimen, you should of course get rid of all the chemicals that are here. Now, the polystyrene trays, they don't conduct heat, so those you can take out with your hands. But the metal in here, this you do need to handle with a pair of pliers because that is very, very cold. Now, the best way to get rid of the liquid ethane that still remains in some of the liquid nitrogen is to just place it on the bench top and either put a snorkel ventilation system over it or place it in a fume hood. Again, if it is on the bench top, it will not explode because remember that the area for an explosion hazard needs to be smaller than 140 liters. Still, you should take care of disposing of this by simply letting it evaporate in either a fume hood or underneath a snorkel system that we have here.